All right, so some more review questions. Let's take a look at 36. So find the fourth degree polynomial with real coefficients that has zeros of 2, 3, and rad 2i. Okay, so what you want to remember from this is that if you have a zero of rad 2i, it's going to come with its partner, friend, negative rad 2i. Okay, so anytime you have an imaginary root, it comes with his buddy, okay, the conjugate. All right, now that I have the four zeros, we're going to set up the factors, and once you have the factors, you just want to multiply them together. So if I have 0 of 2, that means your factor would be x minus 2. A 0 of 3 would give me a factor of x minus 3, x minus rad 2i, and x plus rad 2i. Okay, now we need to multiply all this together. The best way to do it is to multiply like the real numbers first, and then multiply your imaginary numbers, and then we'll multiply that together at the end. Okay, so if we first start with x minus 2 times x minus 3, and we FOIL that, you get x squared minus 3x minus 2x plus 6. Okay, or x squared minus 5x plus 6. Okay, now on the right side with those green ones, FOIL that. X times x is x squared. The inside and outside terms are going to cancel out, right? You have, in the inside 2, you have negative x rad 2i. On the outside, you have positive rad x 2i, so they cancel out. And then the last two terms, rad 2 times rad 2 is 2. I times I is I squared, so we end up with negative 2i squared. Okay, well, negative 2i squared is the same thing as plus 2, right? Because I squared is negative 1. Now we just multiply this one more time. So we're going to distribute x squared times x squared is x to the fourth. X squared times 2 is 2x squared. And we have negative 5 times x squared is negative 5x to the third. Negative 5x times 2 is negative 10x. Then 6 times x squared would be 6x squared. And then 6 times 2 would be 12. And then last, you want to just combine like terms. So you end up with x to the fourth minus 5x to the third. We have some x squareds that will go together, the 2x squared and the 6x squared, giving us 8x squared minus 10x plus 12. All right, 43. So the partial fraction decomposition is when we're going to split it up to the two denominators and figure out what those numerators have to be. Okay, so for on 43, we're going to first rewrite it as what we have equals a over your first denominator. So we're going to split our denominator into the two factors, the x and the x plus 2, and then plus b over x plus 2. Now what we're trying to do is solve for a and b. Okay, so to solve for a and b, the first thing we're going to do is clear our fractions and multiply by the least common denominator, in this case, which is going to be x and x plus 2. Okay, so by doing that, you're going to multiply all of this by x, x plus 2, x, x plus 2, and then x, x plus 2. And we cancel out any common ones and we see what's left. Okay, so this whole denominator goes out. So now you're left with x minus 4 equals. Over here, just the x's cancel, and you have a times x plus 2. And then with the b, the x plus 2's cancel, and you have bx. Okay, so now we want to solve for a and b. So you need to decide, what do we want to make x be? If I want to solve for a, so let's say I'm trying to solve for a first. I'm trying to get the a by itself. To get a by itself, that means our b needs to be 0. So what would b have to be, or what would our x have to be to make this 0? To make that 0, x would have to be 0. Okay, so let's say first, what if x is 0? Okay, and I'm just going to go down here. If x is 0, then you have 0 minus 4 equals a times 0 plus 2 plus b times 0, which is, or 0 times b, yes, which is 0. Okay, so now we have negative 4 equals 2a. So now we've solved for a. A is negative 2. Okay, so now let's go back to that equation and figure out, well, if the next thing I want to do is solve for b. So if I want to solve for b, this needs to be 0 so that I have a times 0 to get rid of the a. So then x would have to be negative 2. So we're going to go back and do all of that stuff if x were negative 2. So actually, let's move it down here. If x is negative 2, then you have negative 2 minus 4 equals a times negative 2 plus 2. Okay, so that's 0, so that's just gone, plus b times negative 2. Okay, so that gives us negative 6 equals negative 2b. So divide by negative 2. B is 3. Okay, so once you have a and b, now we just go ahead and substitute back in. So I substitute back in to this original a over x plus b over x plus 2. So my a, it was negative 2. So you're going to have negative 2 over x plus b was 3. 3 over x plus 2. So that would be the two fractions that add up to make that initial one that you started with. All right, so let's take a look at 44 and 45. These are your interest ones. Compounded quarterly is going to be the formula that says A equals P times 1 plus R over N to the NT. Okay, so quarterly is the number of times, or N is the number of times. A quarterly would mean 4, so 4 is going to be N. The percent, that means our R, as a decimal is going to be 0.1. And it says we invested 1,500, which is going to be your principal. So you're just trying to solve for A. So A equals 1,500 times 1 plus our rate would be 0.1, N would be 4, and then N is 4 again. And then time is how many years? So 12 years. Okay, and then this is just for your calculator. So you do 1,500 times 1 plus 0.1 over 4 to the 48th. Okay, and we should be able to get 4,907.23 cents. Okay, compounded continuously for 45. That's your other equation. A equals PE to the RT. Okay, so 2,000 is invested. So that's your P. E is just E, like the number on your calculator, right? It's 2.7, whatever. We'll leave it as an E. And then the rate, in this case, 7.5 is 0.075. Okay, so then you have 0.075 times T, 20 years. And then again, just type this in the calculator. Okay, so 2,000 times E to the 0.075 times 20 gives you 8,963.38. The doggy wants me too. All right, let's take a look at 52. So 52, write a logarithm as a single quantity because we got to put that all together. Right now it's like this one big multiple things. Okay, so you want to remember that a sum becomes multiplication, a subtraction becomes division, and then that number in the front is going to go back to become exponents on these guys. Okay, so let's see. So first start with any number in front of each individual log is going to go back to become the exponent. So this is going to go back here. This 2 is going to go back here. So let's rewrite that first. So 1/5 log x plus 1, now it's to the third, plus log x minus 1 squared minus log 7. All right, now let's combine. Okay, so the first two that were addition is going to be multiplication. So 1/5 times log x plus 1 to the third, x minus 1 squared. And then the subtraction piece of it, this guy minus log 7, is going to go to the denominator and become division. So divided by 7. Okay, and then the last thing we're going to do is take any other things that are out in front, like that 1/5. Now it gets to go and become an exponent. So you have all of this to the 1/5. Okay, and then 1/5 is the same as 5th root. So you could write it simpler as 5th root. So log, well, let's see. Yeah, let's move these lines. Because it's really not the log doesn't go to the 1/5. Just this stuff goes to the 1/5. So log 5th root, x plus 1 to the 3rd, x minus 1 squared over 7. All right. 58. Let's see. So 3 to the 2x equals 5 to the x minus 1. Okay, so this is one where you would try to find a common base and change to the same base if you could. These two do not have a common base. So what we're going to need to do is log both sides. Okay, so what I mean is this would now become log 3 to the 2x equals log 5 to the x minus 1. Okay, now our exponents get to move to the front. So this 2x goes up here. So 2x times log 3 equals x minus 1 times log 5. Okay, so from here, let's divide both sides by log 5. So if I divide both sides by log 5, I have 2x times log 3 divided by log 5 equals x minus 1. Okay, from here, just go ahead and use your calculator. So 2x times log 3 divided by log 5. And then we are going to add 1 to that to solve for x. Okay, so all in the calculator. You do 2 times log 3 divided by log 5. And that's with an x. Wait, I feel like I don't have my calculator. Hang on. Let me grab it. All right, so let's see. So log 3 divided by log 5. So log 3 divided by log 5. Okay, times 2. Okay, it's 1.365x equals x minus 1. Okay, you're trying to solve for x. So let's just subtract x, then you have 0.365x equals negative 1, and divide both sides by 0.365. So negative 1 divided by 0.365 is negative 2.74. All right, 60. Initial deposit of $3,000 is made in a savings account for which interest is compounded continuously. The balance will double in 7 years. What is the annual rate of interest? Okay, so this time you're trying to find the interest rate. So we are going to use the equation A equals PE to the RT because we're compounded continuously. That tells me I'm going to use this equation. It's 3,000. It's going to double. Okay, so if it's 3,000, it started at 3,000, that's your P. If it's doubling, it's going to become 6,000. E stays E. The rate we do not know. Time is 7. Okay, so first thing you're going to do is divide both sides by 3,000. All right, so now we have 2 equals E to the R7. Okay, so you're going to, from here, you're going to log both sides. So I'm going to use natural log because that'll get rid of our E. So ln2 equals ln E to the R7. R times 7 is going to move to the front. So ln2 equals 7R, or R times 7, ln E. Okay, so if you remember, ln E is equal to 1. Okay, so to get our rate, all I have to do is divide by 7, both sides. So R equals natural log 2 divided by 7. .099, so 9.9%. Okay. All right, 67. So we're going to need a unit circle. 17 pi over 3, which of course is not on the unit circle because it's too big. So you want to find a coterminal angle or figure out what that's equal to. 17 thirds. Well, 3 goes into 17 5 times, which is 15 and 2 thirds. Okay, so if you're on the circle, remember every time we go around, it's 2 pi. So 1 time around is 2 pi. 2 times around is 4 pi. I want to go 5 pi on 2 thirds more. Okay, which puts me there at negative pi over 3. And then we would go to the unit circle. So let's see if I have one here. And figure out what the cosine is there. Well, I can tell you what it is, but let's see. We got crazy pictures now. So here, we'll just steal that one with the writing all over it. No! The dog's yelling at me again. I tell him no. Okay, so negative 1/3 pi is going to be this here. Okay, so 1/2 negative rad 3 over 2, and you're looking for cosine. So our cosine is our x coordinate, so your cosine would be 1/2. Okay, and then 68. Find the cosecant. Cosecant is reciprocal of sine. So sine is opposite over hypotenuse. So cosecant would be hypotenuse over opposite. So on this triangle, your hypotenuse is 15. Opposite side is 5, so we don't even need to do anything here. So cosecant is 15 over 5, or 3. Okay, and then 70. Samuel! Ignore the doggy. Maybe he'll be quiet. All right, so 70, sine graph. First, find the amplitude and the period. So amplitude, absolute value of that number in the front. So absolute value of -2 is 2. Okay, period is 2 pi divided by anything in front of the x. So 2 pi divided by 1/4, which is really 2 pi times 4, or 8 pi. Okay, so now we're just going to set it up. Okay, so if my period's 8 pi, you want to split it into fourths. So, which is nice and easy. Okay, sine graph normally starts in the center, goes up to the right. I have a negative, which just means I'm going to go down to the right. And instead of going just up and down 1, we're going to go up and down 2 because we have amplitude 2. So I'm going to start here, down to the right, up, down, up. So it's going to look like this. And then finish off the pattern, up 2, down. All right. Sorry about the doggy. See you later.